You all are doing good. So today we are going to solve LeetCode problem number 9, 1970. The title is last day where you can still cross. So let's see what the problem statement is saying. So the problem statement is given as there is a one base binary matrix where 0 represents the land cell and 1 represents the water cell. You are given integer row and column. Basically, it is indicating this row and column representing the number of rows and the columns in the matrix. Initially, on the day 0, the entire matrix is land. Basically, 0 represents land, so at the day 0, the entire matrix filled with zeros. This is basically saying it is. However, each day a new cell becomes loaded with water. You are given a one base 2D matrix, 2D array cells, where cells I represents row and column. That on ith day, the cell on the rith row and 3th column, one base coordinates are given, it is saying, will be covered with the water. So basically, it is saying we have given the coordinates. At each day, the given coordinate will become water cell. So what our task is, you want to find the last day that is possible to walk from top to the bottom by only walking on the land cell. Basically, from the top cells, you can start from any cell on the top, and we have to reach the bottom row by only walking on the land cells. So let's see how we can solve this problem. So basically, there are very good examples are given. Let's see by example. So as the problem statement is saying, at the zeroth day, everything is filled with water in the matrix, and one of day, this cell is filled with the land cell. Basically, mm, let me read the problem statement again. Zero represents the land cell. Okay. So at the zeroth day, everything is filled with the land cell, and at the 1th day, what it is saying, like this cell is filled this coordinate in this matrix will fill with the water. So if we fill this coordinate with the water in this matrix, then there are many ways available which we can use to go from the top to the bottom cell. From here to here we can reach, from here to here we can reach. There are many ways. I think there's a problem. There are many ways, like we can go from here to here, this way, as soon as on the second day, what it is saying, this coordinate will become water cell. So this coordinate will become water cell. Still, we have one way to go from the top to the bottom. And on the third day, this is saying that 3 comma 3 will become water cell. Then still we have left with a one way, so we can reach from top to the bottom cell. And on the fourth day, they are saying then one comma one will become also water. 2 comma 2, sorry, 2 comma 2 will also become water. So this cell will become water. So as we can see, there are no ways here left. From we can start from a water cell and like from land cell, and going through all the land cell we can reach to the last cell. There are no ways left. So what was the last day when we can reach from the top to the bottom? This was the third day. So here third day become our answer. So let's see how can we solve this problem. So basically what we can do, like let's take a test case on the whiteboard and then we can understand. Let me take a screenshot of this. So basically, let me erase this first, then see what we can do to solve this problem. So what we can do, we can like what is the easiest way to solve this? We can use brute force approach. What we can do, we can like make we can take our input like grid and then fill the nth coordinate like in we can apply brute force. What we can do, we can fill the grid with the given coordinate from here. Like suppose we fill the empty grid with this only this coordinate, and then we try if we can reach from top to the bottom cell by we can use for going from top to bottom any kind of algorithm like DFS and BFS. Both we can use. So if we do this, so we will see that we can reach from here to here. Then in the so for this time we have our current answer is one. Like at one a day we can reach from top to the bottom. And what we can do, like we are using brute force, right? So we can what we can do, we can try all the coordinates given and see what was the last time, what is the last time when we can reach from top to the bottom cell. So in the next time, what we will do, we will fill our grid with these two cells. So after filling these two cells, we will try using any DFS and BFS kind of algorithm to reach from here, and from here to here. Like on the third day, we will fill these three algorithms. Then it to check the check we can reach from top to bottom or not. So this algorithm will work, but there is a problem in this problem. Suppose this cell row is given us very long. What we are filling our grid, then we are traversing again and again for every cell. We are filling it again and then traversing from top to the bottom. Then it will take a lot of time, and that problem will not be accepted. So what we are doing, we are linearly traversing it and then checking it. Then this solution will lead to the time limit exceed really. Then how can we optimize this kind of problem? Whenever like so, what we can do whenever we arrive uh, the really kind of problem when we are using linearly and we are using a linear kind of algorithm. So what we think we most probably think of a binary search kind of problem. So by the kind of solution. So what we will do here, we will apply binary search algorithm on this. And what we will do, we will suppose we will take the start point as this one and the end point as suppose this length is and n equal to like suppose 5. What we will do a binary search. So in binary search what we do basically at the start and end and divided by 2. So what will be the outcome? 6 plus 1, 7, and the interior division will give us 3. What we will do, we will use this 3 to binary such that at the third day, we can reach from top to down or not. If we can reach, then what we will do, we will keep this 3 as an answer. Like on the third day, we have what? We have reached from top to down and try to increase our answer our days at the higher end so that we can find the last day when we reach to our solution. So in this case, suppose at this index we tried with this this our mid got at this and we try filling all these values. If we succeed after filling these values in a grid and going from top to the bottom by using DFS or BFS, we are successfully able to go from top to the bottom. What we will do, we will store it and then we will set our start as this point and end will be here as previous. And in next, what we will do, we will find mid of this and try if this suppose if the next mid comes here and if this mid, if suppose if this mid satisfies our like after filling if this mid satisfies our condition, then we will apply index of this cell as our answer. So we will fill from here to here all the coordinates in our grid and then check if we are able to go from top to the bottom. Then we will make this our answer, and this is how the binary search works. Basically, this is kind of advanced binary search kind of algorithm. So let's see how we can code this and how it can be used as an improved algorithm for our solution. So I have coded it previously so that it won't take much time of you. So what I have did, I have taken a start and ending. Basically, it is left. I have set it here. as it was one base indexing, and the last point I have stated is here that maybe it can be answer or it can be answer. Basically, our answer can be lie in the range of this. So now, so that's why we have taken ranges because we are applying binary search on the answer. Okay, so we will only apply binary search where our answer can lie. So our answer can lie in this range, no only because this cell is given for the first day, this is for second day, this is for third day, and this is for nth day. So our answer will lie from the first day to the nth day. Then that's why we are only applying binary search in this range. So what we are doing basically, we are first finding the mid, and then we can check if this midth day we are able to go from the top to the bottom cell. If we are successfully able to walk from the top to the bottom, what we do, we just update our answer and set the left set, like so what I as I have explained previously, from here to here. If I and this suppose take as a mid, if I am able to go from the top to the bottom using this mid, what we will do, we will set this start as the mid plus one. So from next time we will apply ranges from here to here. That's ditto same we have did, I have did in this solution. So if this is not possible, then what we will do, we will just try to decrease. We will set the right as the mid minus one so that we can check in the this left side of brain. So let's see what this scan work function does. So what we are doing, as we can move any direction from this in this grid. So we have taken the directions as this is a pretty good trick to walk in the matrices. So what we have did here, let's see. So what we are doing the we are passing here mid and row column, the basically the size of the matrix, how many numbers of rows and the column in the website in the matrices can be. So basically we are finding this and the mid we are getting here and passing and using it here as a day, and like what can be happen at the date index. So what we are doing, we are firstly making this empty grid with the row and column, and in next what we do, we are just filling this grid with the water cell at, till the date index. So basically, if we find like date at this point, so we will fill all these cells as one value in this grid. Basically, what we are doing it here, and in next what we are making a queue, and then what we are doing, we are just if any we are basically filling these values. Let me zoom it here. What we are doing, if we are filling these the coordinate, like the position of these cells in our queue, if they are not water cell. Suppose if we get zero here, then we will insert it into our queue. Basically we are doing it for all the top elements so that we can start working from here to find the way so that we can reset the bottom. So this is basically what I'm doing here. So we have filled all this RQ with those top sales value, and then we fire a BFS from the top and see, like we are getting the rows column, and then we try to traverse in all the directions using this dice tricks which I have explained previously. So what we will do, we will form a new direction from, like if we are stand here, we will try to move from here to here to here to here and here to here. Basically it is optimal to move the left, right, and bottom side. It's not what to move upside. So what basically we are doing, we are moving from the left, right, and bottom direction. So after making new coordinate, we are checking if it is valid or not, or if they are like if the new coordinates are inside the grid or not. If they are inside the grid, what we are checking, the new cell which we are going is land cell or water cell. If it is a like water cell, what we will do, we will continue and we will not not go on that cell, because if we go at that cell, we will not we like we are not allowed to go on the water cell, right? So if all the condition are satisfied, what we will do, we will mark the new cell we are at, as a visited and add that cell in the or BFS, and that's how the BFS go on. And if somehow or any value, any row value will come at the last index, we will understand that we have reached the last cell. We have reached the last cell, so we will return true. So, and the same procedure that I have explained here will work as answer. Like if this will return true here, and we will store our answer, and then the left will become the mid plus one, and then what the solution that will be the like maximum will become our final answer. So I hope I have explained well, and any kind of doubt you can ask in comments. Thank you.